So I'm Brian Jones and welcome to LSOP Live, and this is our first installment. We're trying something new in this era of social distancing. And so I got a group of people here and we are masked and gloved and separated by plexiglass partitions. We are ready to share some science with you. And our topic for today is electricity. So my name is Brian and I'm going to turn it over to our next participant.
Hi everybody, I'm Brenna. I'm a little shop intern. And I'm super excited that you guys are on today.
And a future science teacher.
Hi, my name is Maude. I'm also a little shop intern here at CSU.
All right, and we're going to kick it off, and today we're going to talk about electricity. So this is our first installment of LSOP Live. Here's our splash screen at the start. Woo! And that's done. And next, here's a light bulb. And the way light bulbs work is they're charges, they're electric charges that are moving through the filament of the bulb from here to here. And we can think about it, that I've got a bunch of positive charges piled up here, and they push the other positive charges down, and they're attracted to the negative charges. So there's forces between the charges that are pushing the charges through here. And as they go, there's energy, and that's why the filament heats up, and that's why the filament glows. We're going to come back to some things like that at the end, but first, we're going to look at just forces between charges. And you can try some experiments at home and do forces between charges, and Brenna is going to show us just how.
Hi guys, so I have a roll of Scotch tape right here, and every time you peel off Scotch tape, you build up static charge. If you can see, it's stuck to me, not because it's sticky, but because it's charged. So I'm going to get off 2 pieces here, and I'm going to show you guys something you can do with them. And as you guys probably know, like charges repel and opposite charges attract, and these are just not wanting to cooperate.
They want to attract to you.
Yeah, and the gloves, they are attracted to the gloves. Let's see if I can get them to go.
And this is how you know it's live. This is not a tape. Oh yeah, there they are. Those 2 pieces of tape are definitely repelling each other, pushing each other apart. And this is just a regular roll of tape, and we peel the tape off the roll. And so if anybody wants to try that later, that's how you do it. That is how you do it. And if you put your hand between it, what? They're attracting each other. They're attracting your hand. They're repelling each other. Man, the tape really likes you.
It really does.
Awesome. Awesome. So tape is the easiest way to make something that's static charging. But Maude has a bunch of other stuff to show us.
So a lot of these things you just have at home. So I'm just going to take a ping pong ball and a little piece of fleece, and if I just build up a static charge, like if when you rub a balloon on your hair or something, I'm going to do that. And I'm going to take this big old scarf and a plastic toy stadium horn, and if I charge it up, both of these have positive charges, they should repel each other, and I can move the ball around with the horn. The ball might not be charged enough, but
Well, you're not watching. Your camera's not on.
there we go.
Oh my gosh, and you're pushing the little ball around. Oh, we need more motion than that. Let's get that static crackle.
I don't want them to see my face.
There it goes. There it goes. I'm thinking charge up the ball a little bit more. My stadium horn looks pretty chargy. And if you want to try this, we're just using fleecy fabrics and we're using plasticky things. All right, so we have a nicely charged ping pong ball, nicely charged stadium horn.
They're attracting each other now instead.
Give the ball a little bit of a nudge that starts to roll. There you go. Now see if you can keep it. Yeah, there you go. I think it was just stuck in place with some static charges. Hang around the tray. There it goes. You make it do a loop. Here's our static race around the track. There it goes. There it goes. Go, 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 go. Awesome, awesome. And so we have some like charges repelling each other. And that's just a couple of plasticky bits and a couple of fleecy bits. We've got some awesome static action going on here. Fantastic. Fantastic. And then if you want to do a bigger version of this, one of the things we do in Little Shop of Physics is we share kits of instructional materials with schools. And this is something which we have made a kit on electricity for schools. And this little device makes a huge static charge. And as I put a static charge in this piece of mylar right here, you can see it kind of like plumps out. Oh, well, it wants to attract that light bulb, you scamp. It wants to attract the light bulb. I plump it up, you can see, and so pushing itself apart. If I shake it loose, it's going to repel, and I can push that up in the air, and it will be attracted to my hand as the tape was attracted to Brenna's hand. And if I bring it in, I can discharge it and bring it back down. But the schools have some of these. And so this is something that you might ask your teacher about. When we're all back in person, you can say, hey, I saw that cool Wandy thing that the Little Shop of Physics people were doing. We happen to have so many of those because that's a little something I'd like to try. Now you can use that static electric force. It seems like it's really, really small, but Brenna's going to show us something where she can do something truly impressive. She's going to move something huge with static electricity. Over to Brenna.
Alrighty, so I'm going to set up my little demo here. It's not very difficult, so you can definitely do it at home. I have our jar of salsa. This isn't sponsored by this brand of salsa.
And it doesn't have to be salsa, it could be any jar.
Could be any jar, and then you can use a marble or something else, but I have this big, looks like a giant contact lens. And then,
it might be a giant contact lens.
Maybe
Like
it is.
literally a contact lens from a giant.
Mike Wazowski's contact lens. And I have this board, and I've already marked where it balances, but you guys can play around with that. So I'm going to set it on here. All right, and you know that wood is made from trees, and trees need water to grow. And so this board actually still has water in it, and we can actually pull those water molecules with static charge. So I have my water bottle here. It's just a plain plastic water bottle. And then I have this fleecy cloth, but I also have a ball of yarn over there that you can use too. And it truly does something pretty spectacular.
Oh my gosh, it's pulling the board.
And you can use a piece of PVC pipe. You can use really anything plastic, like Brian said. Let's see if I can get it the other direction. Whoa, come on. Maybe it needs a bit more charge. And also, if you guys can't get this to work, something that does work is if somebody in your house has a blow dryer, you can blow dry these things and it'll take all the moisture out of them. And then they build up the charge even more. But yeah. And I also have a piece of PVC here that we can do it with. It's a little bit more dramatic. There we go.
That's just PVC plumbing pipe, right?
Yes.
It's from the hardware store. Oh, look at that. Look at that. Moving a big, big beam, and you're moving it with static electricity.
Cool.
That is awesome. Now, Brenna said that it's the water in the wood that makes this work, and it turns out water is attracted by electric forces, and it has to do with the way the water molecules are put together. They're positive on one end, they're negative on the other, and they make little dipoles. So water is strongly attracted by static charges, and Maude has a little demonstration to show us that.
Okay, so you can go to any faucet in your house and get yourself a real good stream of water like that. I'm going to use the same stadium horn as before, charge it up.
Oh,
It makes
that
the
is
water.
seriously moving to the, let's really point it to the side. To the top. Oh yeah, I mean you can see it's definitely getting a little bit of that. If we overflow the water, that's fine. There it is. Deflecting the stream of water. Do one more to I want to see that. I want to see that happen one more time. I'm going to see that happen. Oh, look at that. Look at that. That is awesome. That is awesome. And the water droplets that come off the screen are actually heavily charged. And you can use that to build up enough of a charge that you can give your little brother a jolt of electricity. And we might show you how to do that on a future episode. How do I know this, you ask? So that's forces between charges. But the forces between charges is what actually makes electricity go. So if you've got two positive charges that push each other apart, if I have a positive and a negative, they attract. So if I have a place where I've got positive charges and a place where I have negative charges, positive charges in between will go from the positive to the negative. And that's how you make current go in circuits. And Maude has a little demonstration on that.
So humans are full of these things called electrolytes, which are the things that you can get from like Gatorade and Powerade.
Oh yeah, your mom's full of electrolytes.
She is, so is yours. If she weren't, I would be very much more concerned. Basically means that humans are big sacks of just salt and water. And that means that there's a little battery in here that I can close the circuit between one end and the other and make this delightful, delightful sound here.
Not just sound, you're getting light too.
Yeah. And it is just me closing the circuit at each end over and over. And in there is just a little battery, which Brenna can show you how to make one.
What?
Over
Brenna's going
there.
to show us how to make a battery.
Yeah, so you guys can make your own battery at home and you can actually power something. So this is a little digital clock. It runs on about 1 kilovolt, I think, which is about 1,000 volts.
Oh no, sorry, it's about 1.5 volts.
1.5
1
volts.
kilovolt, that would be
That's a lot. Sorry, guys. 1 kilovolt is a lot. So this runs on about, what did you just say, Brian?
About 1.5 volts.
1.5 volts. Okay. So here I have some washers, which are just like some washers you can find at Home Depot. They're galvanized, which means they're coated in zinc. And zinc and copper can work together to pass these electrons around and form a battery. So I have, it goes washer, penny, washer, penny, washer, penny. But then in between each layer, I have a piece of fabric that is soaked in salt water. So the salt water helps facilitate those electrons moving between the layers. And I have, if you look at the back here, I have, my two connections. This is where a battery would usually go. And then I can touch this. Whoop, I just wrecked my battery, guys. Hold on. There we go. I can touch this to the top, hopefully, and get it to go. Come on. There we go.
All right, Brenna is running a clock with washers and pennies.
Just a little bit of salt water. So you guys can definitely do this at home. Maybe you can tear apart one of your parents' clocks if they let you. But I would definitely ask them first.
And this is just a little tiny digital clock, and we got one that just ran off one battery, and that's the key. And then instead of having a battery in it like you would buy at the store, Brenna has made one from parts that you can get at the store with washers and with pennies. And the key thing is the zinc and the copper. Now, there's a bunch of people who are on here, and I'll just mention, if you want to unmute yourself and ask us a question, you can. We're live. And one of the things that's different between this and the broadcast is you can talk back to us. You can talk to us. You can also put things in the chat if you would like. So now that there's a group of people who are on here, if you wanted to ask us a question, how did we do that? Where are we taking it? Go ahead and put it in the chat. We would be happy to talk to you about it. But while we wait for questions to come in, we're going to turn over to Maude, who's got another circuit demonstration for us.
All right, so I've got just a regular little Christmas light here that has been stripped on both sides. One of these wires is coming over here to a battery pack, which is then connected to just your regular old pencil that's been cut in half. And all of your pencils have what is called graphite in them. And graphite can conduct electricity. So if I take the other side of that Christmas light and I put it on the graphite, I can turn it on because I closed the circuit. And what's funny about this is that the farther I will move down the pencil, the more graphite that this power will have to run through and the more resistance it will be facing. So when I go down, the light gets dimmer. So if you look over here, this is going through a lot more graphite because it's all the way at one end of the pencil. So it's a very, very dim light. But if I bring it all the way over here, there's not very much resistance because there's not very much that it has to go through. So it's a much brighter light.
Awesome, thank you. And that's more or less how dimmer switches work in your house. You've got something where you're just going to make some sort of a little slider that's at one end or another of something which is not a particularly great conductor. Ultimately, that's how they go. We got one more, actually got a couple more demonstrations for you. If you have a battery, it's got a positive on one end, negative on the other. It pushes charges from the positive to negative. As they go, they can make things happen. As you saw with Maude, you can make a light bulb light. And Brenna's got something similar.
Alrighty guys, so if we've ever come to your school, you probably got one of these little circuit kits. And this is one of the things that Little Shop does, is provide you with some materials that you can do science with at home. So I'm going to open my circuit kit here, and I have an LED light, 2 magnets that we don't really need right now, and then a battery. So this battery has a positive and a negative terminal, and in order to get the light to turn on, I need to connect those 2 terminals. And if I put the light in between, then you can see it lights up. If I put it the other way, it does not light up. But yeah, there you go.
And a question just came in and someone asked, how can we make the human battery with the lights and the noise? And that's something that we bought as a toy. It was called a sci-fi tube. And so this is something, yeah, you can get these on the internet. If you look up sci-fi tube, you can see that. There's another toy that works like that, that's a ball, and it's called the energy ball. And the key is there's 2 electrodes. And if you connect the circuit between the 2 electrodes, you can make some magic happen. Before we go to our last demonstration, I want to go first to Brenna and then to Maude. And I want to go over the different pieces involved if you want to try any of these things at home. So let's go over to Brenna. Show us the pieces. If people wanted to try the things you did.
Of all the things? Of all the things, Brian? Alrighty. So for the first demo, all you need is a roll of Scotch tape. That's all it takes. And some Scotch tapes, I believe, are charged differently. Isn't that right, Brian?
Some of you charge positive, some of you charge negative.
Yeah, so it just depends on the type of tape. This is a fun, easy experiment. For the moving the board, of course, you're gonna need a board and then some nifty can or jar, and then something to balance your board on. So we have Mike Wazowski's contact lens, but you could definitely use a marble or maybe some kind of pencil. That's part of the fun of science, is you can kind of play around with that stuff too. And then to get it to move, you can use any sort of plasticky thing. You can use an action figure, you can use your bottle, a piece of PVC pipe, and then just some sort of woolly, fleecy fabric. For the do your own battery, all you need is some sort of device, preferably one that only requires 1 battery, as you can see, 2 wires, which probably you have somewhere in your house, and then you need galvanized washers or some other zinc plated material, and copper pennies, and just some paper towels, fabric, or whatever else to put in between. And you soak those in salt water, and there you go. And then for, of course, the circuit kit, you just need this LED bulb and a very small battery that you can buy at the store. But that is all from me.
Now Maude is going to tell us the parts you would need if you wanted to try any of the things that Maude did.
So like Brian mentioned earlier, this is just a sci-fi tube, which you can find online in most places. For the first demonstration I did, here with the ping pong ball, you essentially just need a ping pong ball, maybe a tray to have it lay on so it doesn't roll right off the table. We used a stadium horn because it's a little bit longer, it's more fun to play with like a wand, but we also found that other plastic toys like this pig, this little plastic pig that you can get at a dollar store, also works just as well. And then you need something to charge them up with, so little pieces of fleecy cloth, your mom's scarf, or we use this also works, you know, just a little plushy toy. Or if you've got, you know, your old kid, your little brother's glove, little fleece glove also works. Some of these we used also for the water, like the fleecy things, and then your plastic toy you can use for the water. We just used little receptacle, but you can do this with a small faucet in your house, in your bathroom, or in the kitchen. Definitely works as well. For this circuit, you just need a pencil, just cut in half. We have a bunch of alligator clips here connecting things so that the charges stay safe, and then just tear apart that those Christmas lights that your dad wanted to throw away because some of the bulbs were out. Just recycle those. And then this is just a small battery pack with 2 batteries taped together here. That's all for me.
So those are all things which we'd like for you folks to try at home, okay? And the goal of this Little Shop of Physics Live thing is we're going to show you some things you can try at home. And in future episodes, we're going to tell you in advance, here's the type of thing we want you to bring when you watch, and then you can work along, and we will do that. But we're going to close every episode with something which is really dramatic and really fun. And I'm going to close with something that I don't want you to try at home, but it's just awesome. And I'm going to ask Brenna to hit the lights because this is one we're going to make some light. So I have here, I have a dill pickle, and then I've got 2 wires that are connected to a power supply. And I'm going to turn on the power supply, and I've got my positive terminal here. I've got a negative terminal here. Charges want to go from the positive to the negative. And so if I touch this to the pickle, you can see it actually lights up. It lights up, and it lights up pretty brightly. And this is one we don't want you to try, for one, because it's incredibly stinky. And I think the people here in the room will verify that. But also, too, this is a high voltage power supply. And to make the charges go through the pickle, you need to have a pretty high voltage to make this happen. But this is just a dill pickle from the grocery store, and I can use it to make a light. And the light that you see, for those of you who are into chemistry, it's yellow. It's sodium yellow. I'm making a little sodium arc lamp. And the reason it works this way, because pickles are salty. There's a lot of sodium in that pickle, and that's why I get that. That's why I get that sodium light. It's definitely from the salt in the pickle. Before we close, I want to ask anybody here, do you have any questions before we go? And go ahead and unmute yourself and shout it out, or put it in the chat. All right, and if nobody's got any questions, I'm going to go ahead and close. I will say, if you want to see more things like this, go to our website. We're lsop.colostate.edu, or you can just do a web search on Little Shop of Physics. We're the only thing out there called that. So here's the name you're looking for, Little Shop of Physics. If you go to our website, we've got videos, we've got experiments to try at home, we've got resources for teachers. We'll be back next week with another installment of LSOP Live. And if you want us to deal with a particular topic, then send us an email, drop us a message, let us know what you want us to treat. We're here to serve. Thank you very much. So I'm going to say goodbye and ask Brenna and Maude to say goodbye as well.
Bye, guys. Thank you for hanging out with us today.
Bye, everybody. See you next time.
See you next time.
Thank you.
All righty. Bye-bye, everybody. We'll see you next week on LSOP Live.
Thank you.
Bye.
Bye-bye.